This will be a quick video to look at determining the pH of bases. Take a moment and look at this grid and pick out the strong bases. Notice that I've crossed off the strong acids in green and the weak acids in orange, as I have already addressed those in previous videos. What you see is I have circled 4 bases that follow the Arrhenius definition of bases, meaning that they have OH in their formula. And these particular ones are classified as strong bases, meaning that they dissociate 100% and they will completely dissociate in solution. Notice I'm using the word dissociate because we're talking about dissolving in solution here. So our criteria for determining if a base is a strong base is how soluble it will be in solution. And that is why we know that family 1 alkali form strong bases in solution. We also know that there's some elements in family 2 that will be classified as strong bases in solution because of their solubility. Now we could argue that calcium hydroxide is not that soluble, but its dissociation is still decent enough that we classify it as a strong base. Magnesium hydroxide, however, is much less soluble, so most sources wouldn't call it a strong base, although sometimes you will see it labeled as a strong base just because its dissociation isn't terrible. In other words, it's not completely insoluble, so we could consider it as still fairly competent at releasing OH- when it dissolves in solution. Notice I'm writing a dissociation equation showing that it dissociates completely into ions when it dissolves in solution. I take the negative log of the concentration of the hydroxide ion, that gives me the POH, and then I subtract that value from 14, and that gives me the very basic pH of the lithium hydroxide solution. So what if I wanted to calculate the pH of barium hydroxide? I would have to account for stoichiometry and recognize that 2 hydroxides are given off in the dissociation of barium hydroxide. And I would use this value to calculate the POH and subsequently the pH. How about looking at hydroxides that may not be that soluble? How would I determine their pH? Well, I would have to go back to a KSP calculation to determine how much of this would actually dissolve in solution, dissociate into ions, and only that soluble hydroxide concentration would account for an effect on the final pH of the solution. It's completely doable, but usually beyond the scope of a Chem 12 class, we would just say this is a weak base and leave it there. But it is not impossible for us to calculate the concentration of OH using a KSP expression. And then once we did that, we would be able to use that value to calculate the POH and subsequent pH of solution. That is how we deal with strong and weak Arrhenius bases. Just a note there that this is a cubed value here.